that for a real positive number, or positive real number, a, if a is irrational, then the square root of a is irrational. Right, so we've got our if and then. One thing implies another, left implies right. So we are going to do a proof by contra-positive. Proof, you should always say that this is what you're doing. Proof by contra-positive. So, and one real reason for doing this is that it's a lot easier to write things as rational, than to define things and show things are rational than to show they are irrational. Irrational numbers have a mathematical definition. Irrational numbers, they're kind of just really not rational, which is not something that you can write easily. Okay, so the statement is it's if a is rational, so a is rational. If a is rational, then root a is irrational. Sorry, let me try that again. The statement is if a is irrational, then root a is irrational. So that is the statement. We need the contra-positive of that. Remember, that's the negation. Contra-positive. That is the negation of the right implies the negation of the left. So it would be root a is rational implies that a is rational. Okay, if root a is rational, then a is rational. So you can hopefully see how much easier it's going to be to prove this. And once we've proven this, it's enough to prove the original statement. So suppose root a is rational. I'm just going to prove this directly. So we're assuming that the left-hand side is true, and then we're going to show that with this being the case, the right-hand side must also be true. So if a is rational, then that means, or root a, that means root a equals p over q, where p and q are both integers. And remember, the one you're dividing by cannot be 0. Q cannot be 0. You could add a third condition in whereby they don't have any common factors other than 1. I don't think we need it for this, but if you're worried, just put it in anyway. It won't do you any harm. Right, so now we've got root a. We're going to now find an expression for a, and we're going to square both sides. So a is going to be p over q squared, right? A equals p squared over q squared, and if you look at that, you have an integer over a non-zero integer. And we know that because we've already defined p as an integer and q as an integer that's not 0. So once you square them, those properties are still true. So a must be rational. Which means contra-positive is true. Is true, and so original statement must also be true.